weak acids. Weak acid will ionized or dissociated partially in solution. The pH of a weak acid can be found if we know A. the concentration of the acid, B. the Ka value of the acid. The generic equation of a weak acid is Ha aqueous dissociating to H plus aqueous plus A minus aqueous. A minus is the conjugate base of the acid. Ka is the dissociation constant. Expression for Ka equals concentration of H plus times the concentration of conjugate base divided by the concentration of the acid. Because it's a weak acid, the concentration of H plus will be equal to the concentration of the conjugate base. We can say let X equals the concentration of the H plus. Ka will be equal to X times X over concentration of the acid. Since X equals H plus, so that's X, and H plus equals A minus, that's also X, that's the other X. Ka equals X squared over Ha concentration. Multiply both sides by the concentration of acid to get rid of the denominator. X squared equals Ka times Ha concentration. X equals root Ka times concentration of Ha. What we did was we square root both sides of the equation. We know X equals H plus concentration, therefore we can replace X with H plus concentration. We also know pH equals minus log base 10 times the concentration. We can replace the concentration here with the root Ka times concentration of acid here. So the H plus is now replaced with this. So the pH depends on the Ka and concentration of acid. And that's what we said here. The pH of weak acid can be found if we know the concentration of acid, Ha concentration, and the Ka value of the acid, the Ka value. So pH depends on Ka and concentration of Ha acid. Here's a question. Work out the pH of 0.01 mole per decimeter cube of ethanoic acid at 298 Kelvin with Ka value of 1.74 times 10 to the power minus 5 mole per decimeter cube. Ethanoic acid will dissociate partially because it's a weak acid. So you get H plus aqueous plus CH3 COO minus aqueous. And that's the Ka value. Ka value for the dissociation of ethanoic acid, H plus concentration times the CH3COO minus concentration divided by the ethanoic acid concentration. The stoichiometric mole of H plus and the conjugate base CH3COO minus is ratio 1:1, and that's what that is. Because they're ratio 1:1, their concentration are equal in the same volume. The concentration of H plus is equal to the concentration of conjugate base. I can then write the concentration of H plus squared because that is also H plus concentration. It's same as the conjugate base. To get the concentration of H plus, I multiply both sides of this equation by the concentration of the acid, and then you get Ka times the concentration of acid, and then I square root both sides to get concentration of H plus. So H plus now equals root Ka times the concentration of the acid. Now I need to plug in the value of Ka and concentration of acid, which is 1.74 times 10 to the power minus 5 times 0.01, and that gives when you root it, it gives 4.1733 times 10 to the power minus 4 mole per decimeter cube. pH equals minus log base 10 times the concentration of H plus the pH then equals minus log base 10 times 4.1733 times 10 to the power minus 4. And that value gives 3.38. So the pH is 3.38 to 3 significant figures.